Hello everyone, this is the math fundamentals on our second lesson discovering what is probabilities 0 to 1. In today's lesson, we will going to learn about what is probability and why is it important. What are the keywords in probability? What are the outcomes in rock, paper, scissors, and how do you write it in probability? How to graph them in both tree diagram and two-way table. And additionally, some practice question for you guys. Let's move on. So what is actually probability? Probability is a chance. It is basically how likely something is about to happen. Whenever we are unsure about the outcomes of an event, we can talk about the probabilities of certain outcomes, how likely they are. As you can see, there's a dice in here currently. And in dice, there are 6 different faces. 1, 2, 3, 4, 5, and lastly, the 6-sided dice. The total outcomes that we have is 6. And if the question asks, what is the probability? What is the chance of getting 5? Of rolling a 5 in the dice? It would be 1/6. Because out of total 1, 2, 3, 4, 5, and 6 outcomes, there's only 1 5. Only 1 5. That's why that 1 5 goes here, and all the 6 goes to the denominator. Let's try with it. Heads and tails. Heads and tails. In coin flip, there are only 2 outcomes. And the probability of getting heads would be 1. 1/2. That's it. The chance of how likely we're getting heads. 1/2, half. Now, what are the keywords and probabilities? Probabilities can be measured between 0 to 1. If the probability of a certain event is 0, it is impossible to happen. If it is 1, it will certainly happen. Impossible, certain. So, if it's 0, it's impossible. If it's 0.25, it's unlikely. 0.5 is half-half, so it's equally likely. 0.75 is 75%, so it's more likely. 1 is 100%, so that's certain. To help you understand, something that's not able to be happen is I am eating while studying while exercising while while reading while singing. You can't do all of those in together. That's why it's called impossible. What's certain is, as a student, they will go to school. That's certain. As a student, you must go to school. Now, how do you write down probabilities? In this question, I will use rock as R, scissors as S, and paper as P. And let's think that there's John and Jason here. Now, when John puts in rock, the probability that Jason does something is he could rather do a rock together, or he could do a scissor, or he could do a paper. When John does a rock, Jason has 3 options. When John does a scissor, Jason could either do rock, scissor, or paper. Now lastly, when John does the paper, Jason could rather do rock, scissor, or paper. There are total 1, 2, 3, 4, 5, 6, 7, 8, 9 sets. And if the question asks, what is the probability that John and Jason both does rock? There's only one option in which John and Jason both does rock. And therefore, out of total 9 outcomes, it would be 1. However, the question is asking, what is the probability that John and Jason will both put the same shape of hand, or same rock, paper, scissors? There are only 3, which is both putting rock, both putting scissor, or both doing paper, out of those 9. So out of 9 would be 3. Simplifying would be 1/3. That's the probability of having the same, or putting the same rock, paper, scissors. Now we should know how to graph them. Graphing them in terms of tree diagram and two-way table. Now tree diagram looks like this. So first, I'll use the rock, paper, scissors that we have used. So John has 3 options: rock, paper, scissor. When John does rock, Jason could either do rock, paper, or scissor. When John does paper, Jason could do better rock, paper, and scissor. When John does a scissor, Jason could either do rock, paper, or scissor. Now that's so simple. When John does rock, Jason does rock. When John does rock, Jason goes paper. When John goes rock, Jason goes scissor. How that really works. Now that makes it easier for us to find. If the question asks, what is the probability of John doing rock and Jason doing paper, you can just see John doing rock, Jason doing paper. Oh, that's the 1. 1 out of 9. Just like that. Or what's the probability that one of them does scissor? So anything with scissor. 1. Okay, 2. Okay, I'll use another canoe. And then 1, 2, 3. So in total, 1, 2, 3, 2, 3, 4, 5. So the probability would be 5/9. That's how we craft tree diagram. The two-way table looks like this. Yes. So this is rock. This is paper. This is scissor. Rock, paper, scissor. Easy. John and Jason. Rock, paper, rock, scissor, paper, rock, paper, 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 scissor, scissor, rock, scissor, paper, scissor, scissor. Just like that. That's how we craft the two-way table. Now, before going, here is the practice question for you guys to solve. Please pause the video, and when you're done, resume the video. I'll give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. A friend is going to roll a 6-sided die. If I roll an even number, we will play checkers. If I roll odd number, we will play chess. So odd and even. These are the keywords there. I know we're going to play chess because it's more likely I'll roll an odd number. Is your friend correct? Which is more likely, rolling an odd number or even number? Show your probability calculation as fraction and percentages. Use your calculations to confirm and refute your friend's claim. In the dice, there is, in a 6-sided dice, as mentioned, there's 1, 2, 3, 4, 5, and 6. Now we should see what are the even and odd numbers. The odd numbers here are 1, 3, and 5. They are odd numbers. While the 2, the 4, and the 6 are even numbers. There's 3, both of them. The probability of even number is 3/6, which is half. Probability of odd number is also 3/6, which is 1/2. Therefore, they are same. And 1/2 is 50%. Both of them. Meaning that their percentage are same. And therefore, your friend is wrong. And therefore, the friend's claim is wrong. That's it for today, and see you on the next video. Bye.